The moment has arrived. We've discovered the first signs of life beyond Earth. The James Webb Space Telescope has identified a planet that might be even more hospitable to life than our own world. Biomarkers detected in the atmosphere of the exoplanet K2-18b suggest it's covered by a vast, extraordinary ocean. But how can we determine if intelligent life exists there? Can James Webb and other instruments provide us with clues? And if so, is it ever possible for us to reach K2-18b? The hunt for exoplanets is in full force. The James Webb Telescope, the new shining star in our night sky, isn't just looking back to the origins of the universe, it's also focusing on distant planets. We've only been able to detect planets outside our solar system since 1995 because they're incredibly small, and until recently, our telescopes weren't powerful enough to spot them. Consider this image of Earth taken by Voyager 1 in the early 1990s, it's just a tiny dot. And at that time, Voyager 1 was still within our solar system, about 6 billion kilometers from Earth. To put things in perspective, the closest stars in the Alpha Centauri system are over 41 trillion kilometers away. That really puts into perspective just how tiny planets are within the vastness of the cosmos. Tracking them down has always been a bit like detective work. Scientists use a clever technique. These tiny planets become visible when they pass in front of their stars. This approach is known as the transit method. Another technique detects planets by observing the subtle gravitational effects they have on their stars' movements. Neither method is completely foolproof, but together they've helped us discover over 5,000 exoplanets so far. The next challenge is figuring out if any of these worlds resemble our own. Until recently, it was difficult to determine crucial details like whether these planets have atmospheres or water. We could only estimate if they were dense, rocky planets or lighter gas giants. Everything changed with the James Webb Space Telescope. This powerful instrument can analyze the light reflected off a planet to detect specific markers, like water and other signs of life. Imagine the excitement when James Webb found evidence of life-related gases, such as methane and carbon dioxide, in the atmosphere of the exoplanet K2-18b. The moment has arrived. We've found the first hints of life beyond Earth. The James Webb Telescope has identified a planet potentially even more hospitable than our own. Biomarkers in K2-18b's atmosphere suggest it's covered by a vast, extraordinary ocean. But how do we find out if intelligent life exists there? Can James Webb or other telescopes provide clues? And if so, could we ever travel to K2-18b? The hunt for exoplanets is in full swing. James Webb, the new shining star in the night sky, isn't just looking back at the origins of the universe, it's also zooming in on these distant worlds. Before 1995, we hadn't even been able to detect planets outside our solar system because they're so tiny and faint. Take a look at this iconic image of Earth captured by Voyager 1 in the early 1990s, just a tiny dot. And Voyager 1 was still relatively close, about 6 billion kilometers from Earth. To reach the nearest stars in the Alpha Centauri system, though, it's a mind-boggling 41.32 trillion kilometers away. The James Webb Space Telescope is a remarkable achievement in modern astronomy, equipped with some of the most sophisticated instruments ever launched into space. JWST has a unique capability to detect and study exoplanets in extraordinary detail. Its wealth of data and precise measurements exceed even the most ambitious expectations of scientists. At the heart of its technology is the Near-Infrared Camera, or NIRCam, specifically designed for observations in the near-infrared spectrum. This eye of the telescope can capture the faintest light from stars in distant galaxies and plays a crucial role in spotting exoplanets orbiting their stars. Another key instrument is the Near-Infrared Spectrograph, or NIRSpec, which splits the light from stars and planets into its component colors. By analyzing these spectra, scientists can determine the chemical makeup of exoplanets and their atmospheres. Every element and gas emits a unique light signature that JWST can detect and study across vast distances. Thanks to this incredible technology, we can now peer into the atmospheres of far-off worlds and uncover their hidden secrets. The mid-infrared instrument, known as MIRI, takes this even further by detecting wavelengths of light invisible to the human eye. MIRI can observe thermal radiation from cooler objects, like newborn stars or dusty disks around young stars, measure the heat emitted by exoplanets, and potentially analyze weather patterns on these distant worlds. The James Webb Space Telescope has detected compelling evidence of carbon-based molecules in the atmosphere of the exoplanet K2-18b. Analysis of the planet's data reveals the presence of methane and carbon dioxide, both important carbon-containing molecules. Carbon is a fundamental element for life as we know it and is often regarded by biologists as the backbone of all known living organisms on Earth. Therefore, finding carbon-based molecules in the atmosphere of a planet or moon could suggest biological activity. Methane, a simple molecule made of one carbon atom bonded to 4 hydrogen atoms, is primarily produced by biological processes on Earth, such as digestion and decomposition. While it can also originate from geological activity, the detection of methane in a planet's atmosphere strongly hints at potential biological processes. Similarly, carbon dioxide is something we exhale and is widely produced by industrial activities here on Earth. On K2-18b, its presence could signal cellular respiration, making it another potential biosignature. However, CO2 alone is not definitive evidence of life, as it can also be released in large amounts through non-biological means like volcanic activity. By closely examining K2-18b, scientists hope to better understand these signals and what they might mean for the possibility of life beyond our planet. We can quickly rule out volcanism as the cause when searching for life. The ratio of carbon dioxide to other gases in a planet's atmosphere plays a crucial role. When multiple biomarkers appear together, the likelihood of life increases. Imagine a planet about 2.6 times the size of Earth, covered entirely by a vast ocean. These are known as Hycean worlds, a fascinating new category of planets. Technically called sub-Neptunian planets, they have captured the interest of researchers. The James Webb Space Telescope discovered significant amounts of water and a hydrogen-rich atmosphere on K2-18b, suggesting this planet might harbor a vast ocean and potentially life. This exoplanet, with 8.6 times Earth's mass, orbits the cool dwarf star K2-18 within the habitable zone, located 120 light-years from Earth. Its size falls between Earth and Neptune, and the presence of methane and carbon dioxide, alongside the absence of ammonia, supports the idea of a water ocean beneath a hydrogen-rich atmosphere. James Webb also detected a promising molecule called dimethyl sulfide, DMS. On Earth, DMS is produced exclusively by life, mostly from phytoplankton in marine environments. Upcoming observations by Webb are expected to confirm these findings, bringing us closer to knowing with great confidence that biological life exists on K2-18b. Life on other planets could range from simple organisms like plankton, algae, and microorganisms to more complex creatures such as fish or aquatic mammals. Importantly, we should always keep an open mind to the possibility of life forms beyond our imagination. Even on a planet entirely covered by water, higher life forms might exist, having adapted to an aquatic environment. Whether K2-18b has any land masses remains uncertain, as it is challenging to determine such details from afar. What's truly exciting is that the James Webb Space Telescope's mid-infrared instrument, MIRI, can detect artificial light emissions, such as those produced by cities on distant worlds. This capability represents a significant leap forward in our search for extraterrestrial life. It's worth noting that K2-18b was not discovered by James Webb. Initial observations of its atmosphere came from the Hubble Space Telescope. These promising findings sparked further interest, leading researchers to study the planet again with the new telescope, and their efforts have certainly paid off. The research surrounding K2-18b is truly fascinating and could mark our first discovery of signs of life beyond Earth. This is a groundbreaking moment, considering we have been searching for extraterrestrial life for nearly a century without success. So far, no life forms have been found anywhere in our solar system, though the icy moons orbiting Jupiter and Saturn remain promising candidates. According to scientists, Hycean exoplanets, planets with vast oceans and thick atmospheres, could be true superworlds and potential cradles of rich, diverse life. On Earth, life began in water, with land masses and mammals emerging much later. If Earth had remained a water world, intelligent aquatic life forms might have evolved entirely underwater. Traditionally, the search for extraterrestrial life has focused on smaller, rocky exoplanets similar to Earth. However, these larger Hycean worlds are now gaining attention as some of the most promising places in the cosmos to harbor life. Not all researchers are optimistic, though. Some worry that the oceans on these planets might be too hot to support life or might not even remain in liquid form, turning these planets into massive steam baths.